Very warm good evening to one and all gathered here. Today, we are going to see the importance of computational method techniques. In that, we are going to see about a simple heuristic algorithm, eigen value using power method. We are going to see the different iterative steps that are implemented in relative randomization approximation of a eigen vector of a given pair under every successive iteration steps. Before moving to the concept, why computational method is considered to be a very broad area in engineering domain. Particularly speaking, in mechanical engineering, you take a heat transfer equation or heat transfer problem. If I want to find out the answer solution just within a span of 10 to 15 minutes time period, then I have to use some tool or an approach, software tool or an approach to find out the output with the help of the computational software tools like ANSYS, using simulation, computational fluid dynamics like that. Okay. So every engineering department, the domain has certain uh, optimistic model solver to find out the output within a reasonable amount of time for a given complex real world practical situation. Okay, this is just a preamble I'm giving to you. Why computational method, the techniques are widely used nowadays in various fields of engineering. Now we will go to the concept of algorithm, eigenvalue using power method. So here we have to assume a square matrix, let us say A. Initially, we have to initialize a square matrix A as like previous methods like in Jacobi, Gauss Seidel method, Gauss elimination. There are different uh, the computation algorithms are in literature which follows the iterative steps. Similar to that, this algorithm also eigenvector using power method obeys the same method of operation. And for that initial approximation, you have to go for an initial guess. Let us say x naught. So for random approximation of solution, under every end of the iteration, we want to include the initial the guess or the starting solution which has been generated previously in order to find out the output for the next consecutive future iteration a given problem. Now we will go to the simple illustrative demonstrative example. So perform an approximation for a given dominant eigenvector square matrix which has two rows and two columns. Solve using power method. So perform up to 6 iterations in order to get the approximation of dominant eigenvector from the given square matrix A is equal to 2 minus 12, 1 minus 5. This is the given dominant eigenvector square matrix. Now coming to the solution. Before moving to the iterative part, so x naught is the non-zero approximation, the column matrix value. So we have to start with initial non-zero approximation value. X naught is equal to 1, 1. It has one column. and 2 rows. Okay. Now begin the solution procedure in such a way. First iteration x1 is equal to a into x naught, where a is the dominant eigenvector, x naught is the non-zero approximation value. So a into x naught. So multiply row with the column, first row with the column. In order to obtain this number, say 2 into 1 minus 12 into 1, so that you will get minus 10. Okay. Similarly, second row, the corresponding x naught vector, 1 into 1 minus 5 into 1, you will obtain minus 4. Now this is the eigenvector pair which is obtained at the end of the first completion of the first iteration. Now we want to scale up the value by reducing the number to the lowest possible limit. So here minus 4 is the most least value from the matrix. So take that out as a common factor and divide that value in the existing solution. How? Say minus 10 by 4 minus 4 will get 2.50. So 10 divided by 4. Further reduce the number from the larger to the lowest value. 4 by 4, 1.00. So from the largest value to the lowest value, we have randomized by dividing the common factor by taking outside the matrix. And this number is commonly divided for both the value that has been present here in the inside the matrix. Likewise, we have to do the same process for the remaining 5 subsequent set of iteration. Say x2 is equal to a into x1. Here, what is x1? The solution which we obtained from the starting point from the initial previous iteration. That will be updated here along with the A matrix. Then again we want to do the random relative approximation by using power method. So here 2 into minus 10 minus 12 into minus 4. So you will get 28. Similarly 1 into minus 10 minus 5 into minus 4. So 10. So bring 10 as a common term outside and divide that number with the 28. 28 by 10 and 10 by 10. So this is the further reduction in the pair of eigenvector value. So the same procedure is continued up to the last 6th iteration. So this is a repetitive step. So with this, what I conclude here from this eigenvector using power method, we want to find out the convergence out of the 6 iteration, which iteration the above problem tries to converge. That is, it is nothing but a stopping criterion. So you take the last 6th iteration. So here the rule of convergence can be applied in order to terminate the end of solution. Further, we cannot able to solve it because only for 6 iteration we can able to find out the approximation model for this kind of method. So this can be solved either manually or with the help of C, Pascal, Fortran, various software tools. So with this, I thank you one and all. So in the next meeting, we will see the same topic, some other the most relative interesting computational method. The next meeting. Thank you one and all gathered here.